Hello everyone, welcome to another video. In this video, I would like to talk about the real world cloud engineer day-to-day tasks. So in my last organization, I used to work as a cloud and DevOps engineer. So I was in a shared role where I used to perform both the responsibilities. So I have made a list of all my day-to-day tasks that comes under cloud engineer umbrella, and also I'm going to talk about a few projects that I was handling there. So if in an interview someone asks you about your day-to-day tasks as a cloud engineer, you can quote all these along with the projects. So it's going to help you answer this question in the interview. All right, so let's start. So I'm going to start with point number one, where I used to manage two public facing production applications for my client. So we had two applications which were built on EC2 instances inside auto scaling groups, and we were using application load balancer, the public one, to expose these two applications to the to our users. And this application was using Apache and PHP, and it was built on Drupal. Okay, so my responsibilities on these two websites were, so the EC2 instances that were running. So whenever the instances need any patching, I mean it can be for I mean it was mostly for security updates. So our security team used to keep updating us on any vulnerabilities that are being reported, because we had a weekly scan that used to run in our entire infrastructure. So whenever any vulnerabilities were reported on the EC2 instances that were hosting these two websites, I used to patch those instances. Okay, and then if there's a requirement to upgrade any application package for uh, these two websites, in that case also I used to update the AMI that was used to create this EC2 instance for these two applications. So building and updating AMI was also my like day-to-day task there. Okay, and then once again, to do that we need to follow the right process where we're not having any downtime. So all that I used to take care there for these two critical websites which were built on Apache and PHP and Drupal. Okay, so these three were the main components of that application. And these two applications were also using a database to store all the data that was being generated from the website, and we were using an RDS instance there. So in AWS we have relational database service, so we were using this, and we were using a MariaDB engine within RDS. So once again, as part of my cloud engineer responsibility there, I used to manage these two RDS instances. Especially, I'm talking about production. I mean, we used to have three environments there: Dev, QA, and Prod. But specifically, I'm talking about production because Dev and QA are still easy. You still have some room there, but in production, you have to be really careful with all the processes, all the things that you are doing, and it is like properly documented. Every production application had a database, and those databases were hosted on AWS RDS using the MariaDB engine. So before any change, so generally these are application level changes. So application teams used to reach out to us. They used to raise a ticket to us that we need the backup of our database before we do any change, so that in case something fails and we need to restore the database from the past, so we have the backup just before the change. So I used to take manual backups of these RDS instances from time to time. Okay, and if something went wrong, then we always have an option to roll it back immediately. Okay, but just remember that AWS RDS also comes with automated backups, so those were still there, but we used to take manual backups also just before the change. So around this database, if I talk about, so I used to take a pre-change backups for restore planning. And since RDS instance is managed by AWS, even then AWS used to provide us updates that can be applied to these instances. So we used to decide on the right maintenance window, and then I used to apply those upgrades to RDS instances as well. Okay, so applying RDS patch upgrades released by AWS. Then of course I used to continually monitor these, so I used to take care of it. At that time we were using CloudWatch only to monitor the performance and availability of these RDS instances. And if there are any changes, I used to inform the application team also that there's a patch upgrade released by AWS which we need to apply on our RDS instances. So just let me know the right window so that I can apply these. Then a third one is, so as I mentioned, I had three different accounts. So in these three AWS accounts, I used to have close to 200 Linux servers, which I used to manage on my own, basically, because I was the only cloud engineer there. So I used to do OS patching across environments for all these different servers. And as I mentioned, security vulnerability remediation was a day-to-day task. Okay, we used to have daily not daily. I mean, we used to have weekly reports of all the security vulnerabilities. Basically, I'm talking about the CVE IDs that were reported with any of these instances. So I used to, I mean, patch them. Security team used to take uh, regular uh, updates as well. So yeah, this was also there. Then we were also following AWS compliance standards. Okay, so AWS also has a compliance standard which the company who is using their infrastructure wants to use. So we also had it. So in terms of compliance requirements, it's part of security only, but a type of a separate segment apart from security vulnerabilities. So I used to take care of all the compliance stuff as well, okay, related to all the resources in AWS. Like if you have a password which is not safe, so all that it comes under compliance. So I used to fix all that as well. Then all these servers, I mean, whosoever has access, so I used to manage the access as well. So for example, there's a new person that has joined our team. It can be developer or it can be like a test engineer, or I mean, it can be any person who has joined your organization and he needs some access in AWS. So I used to manage that. Okay, especially I'm talking about these servers which these new users wants to access. So I used to like configure the access for them. Then, as I mentioned, IAM access management and security control. So as a whole in AWS as well. So I gave this example: a new developer joins and needs access to a specific EC2 instance. So I used to manage his access. If someone has a requirement to have a read-only access to a particular S3 bucket in any of the AWS accounts, so once again, he or she needs to raise a ticket to our team, and then we used to configure the access. Okay, and yes, access in dev and queue is always quick, but in production, if someone needs access to any critical resource, then we always go through approval. So these type of requests used to be approved by our client manager, client infrastructure manager. I also managed IAM access keys that had to be rotated regularly and securely stored in a password manager called Delinea. So there we were using a password manager tool called Delinea. You can search around this, how this tool works. So there we used to store all the access keys, all the sensitive information, all the passwords, IAM access keys in this tool. So these keys, though it is not a secured way to create access keys and use it, but in some cases we did not have the option to use IAM roles. So in those cases we were using IAM access keys, and these keys had to be regularly rotated. So once again, our security team used to inform us that there are some keys which are really old and we need to rotate it. So all that I was doing as part of my cloud engineer role, and I was storing all these in this tool called Delinea. Then cost optimization through automation. So I'm going to talk about my project now. So as part of this cost optimization project that I was doing, uh, so we had some EC2 instances which weren't in use after business hours. So for example, 10 a.m. to 6 p.m. It was being used, and after that we weren't really using it. So what I did, I deployed a solution where I was using AWS Lambda. So I created a Lambda function in Python, and I used a Python with a Boto 3 SDK. So this is a very popular Python library that you can use. So I created one Lambda function, and I configured it to stop a few EC2 instances after business hours and start them again before the next business day. So, and I used to do this via automation using Event Bridge schedule. So AWS Event Bridge is another service where you can create a schedule. Okay, so you can say it's like a cron job that you can create in EventBridge to create the schedule to start and stop EC2 instances. So this was the project that I did, and it really helped us reduce our monthly cost of that particular AWS account where these EC2 instances were. Then, so as I mentioned, I was in a shared role, so cloud and DevOps role. So I had a lot of DevOps based responsibilities, but here I'm just talking about a few because here I'm just talking about the cloud engineer roles and responsibilities. So I used to build CI/CD pipelines in AWS using code commit, code build, and a code pipeline was our solution, which used to use all these tools, integrate together, and deploy our tasks. So basically, I was using ECS there, Elastic Container Service, to create the containerized application which runs as tasks in ECS service. Okay, so if I talk about the flow, so the developer is going to push the code to code commit, it gets built. Okay, it gets built, turned into a container image, and automatically deployed behind a load balancer as an ECS task, so users can access it. So this was the entire flow. We were using code pipeline to integrate code commit, code build, ECR and ECS together, and the application was used to be exposed via an application load balancer to the users. So this was the flow that we were using. So these are the applications that I was using to create this flow to establish CI/CD pipelines for certain business applications. So if I talk about one example where I use CI/CD pipeline, so this is a real project that I did. Okay, so since I was working for a law firm, so one application that I deployed was directly used by our lawyers basically in the company. So what happened? They received raw property data related to home loan applications. So these lawyers used to verify the property before the home loan is approved for any customer by the banks. So they get some data of all these properties and for all the customers, and they used to verify this data. The data that they got was technically correct, but it was not in a usable form. So our developers, I mean, we had a team of Python developers there. They built a solution to make this data usable to them in a short amount of time. So they built a Python-based Streamlit front-end application, uh, which was deployed as ECS task in AWS, and the application had the logic to transform this raw data into a structured Excel file. So they used to just upload the lawyers used to upload their raw Excel file, and then they can download their a processed Excel file which had the data in the usable format. So it was a simple application where we just built a simple user interface where the lawyers could upload the data used to process, and then they can download this to have the data in a usable form that they can later use to verify the property and the customers. So this application ran as a container on Elastic Container Service and was fully integrated into a CI/CD pipeline. So this was the entire flow. So the lawyer used to upload data to this application, which had a UI, and it was running as an ECS task. It was a Streamlit app in Python, and application runs its business logic, and the new Excel file got generated, and then the lawyers can download that file. Then if I talk about another project that I was part of, so we had few developers who wanted start and stop access to their respective virtual machines, which were EC2 instances, but security policies in the company like prohibited to give developers the AWS console access. So then what I did, I researched around and I found that we can build like a separate user interface portal for the users using shell scripting basically. So this project used to have one UI which can be used by these developers to start and stop their respective EC2 instances without having to access the AWS console. Okay, so this solution helped the developers, allowed developers to manage only their own instances, enforce strict permissions, and remove the need for console access entirely. So this reduced the risk while improving developers' productivity. We could have given the access to them as AWS console to the AWS console as well, but our security policies weren't accepting that. So that's why I built a shell script based UI portal. And I have one video on this actually end to end where I've shown you how to build this type of solution where the users can start and stop the instances from a user interface using shell scripting without interacting with the main AWS management console. So you can take a look at that as well. I'm going to put the URL of that project in the description of this video. Then in terms of backup snapshot and disaster readiness, so I used to manage all the EBS volumes for all the EC2 instances that I used to manage across the 3 accounts. We were using AWS backup service where we can create the different backup plans depending on the use case. So I used to take regular automated backups using this AWS backup, and EBS volume backups are critical. So whenever something goes wrong with any other change, you always have the option to go back to the previous configuration of your EC2 instances. Then for all the container images that we had for all the projects where we had containerized applications, so we used to store all the images in ECR, Elastic Container Registry in AWS. So we were using a tool called Tenable to scan these repositories. Okay, so to scan these repositories where we had all the container images for vulnerabilities, and we had a solution which was given by Tenable to us. So it was a Docker container which had a scanning process that used to authenticate to our ECR repositories, scan the images, and then publish the report to a Tenable UI. Okay, so there we used to check all the images and along with their vulnerabilities, and then we start working on those vulnerabilities, and depends on what type of vulnerability it is. If it is an OS level one, then we had to fix it. If it was related to some application package, then the request is going to go to the application developer teams to remediate that particular vulnerability. So this was a solution that we were using for image scanning and security for all the container images that was stored in ECR using Tenable solution. Tenable Docker container basically. Then I used to manage all the SSL certificates as well. So from time to time, our SSL certificates used to expire. So we were using AWS certificate manager, but we were trying to we had all our certificates in another tool called DigiCert basically, but we used to import those certificates from DigiCert to ACM and then use it with all the different resources. If I talk about one example, so all our application load balancers which were hosting our application, they had some they all had SSL certificates. We used to expire from time to time, so we used to renew those certificates as well. Okay, so all that I was taking care of as part of my cloud engineer responsibilities. Then in Route 53 also, if we have a new application deployed for which we need to create another new record in Route 53 hosted zone, so I used to create DNS records as well. Okay, once again, in general, we used to use a simple routing policy only for all these records, but in some cases we can use other policies as well depending on a particular use case. So I used to create the new DNS records in our own Route 53 hosted zones for the new applications as well. Then if I talk about another project that I was part of, so I built a solution to do a log aggregation using the a traditional syslog server capability in Linux. So we had a server. So this server was actually on VMware. Okay, so we had some infra on VMware as well. So on VMware we had a server. It was using CentOS 8 stream at that time. So it was a syslog. It was configured to be a syslog server which used to accept logs from all the devices. All the devices means all our other Linux servers, our main application Linux servers, our Cisco networking devices, our firewalls, all the security appliances. We configured all these to send the logs to a centralized server, which was using a syslog capability to store all the logs. Okay, so this is like a solution where we want to have one central place to see all the logs from all the devices. So this was one of the project that I did. Once again, I have a video just on that, and I'm going to put the URL of that video in the description of this video. You can take a look how I configured this solution. Then monitoring alerts and auto scaling. So for all our EC2 instances, we used to create a lot of CloudWatch alarms as well, where we were monitoring the CPU utilization of all these, and we used to have alarms and SNS based email notifications as well. SNS stands for Simple Notification Service in AWS, which is a service which you can use to get notified for certain events that happen in your AWS account. So we used to have these type of notifications there. Once again, I have an entire project just on that to do the hands-on demo in your own laptop. So you can take a look at that video as well. So as I mentioned, we're using Cloud Virtual Alarms for EC2 instances. EC2 instances were part of auto scaling group. In auto scaling group, we can create scaling policies as well, which are triggered on the basis of the CloudWatch alarm trigger. So whenever the CloudWatch alarm triggers after CPU utilization of our EC2 instances reaches a certain threshold that we configure as part of our scaling policy, the scaling policy is going to trigger and it's going to add an additional EC2 instance to our existing auto scaling group to handle that additional CPU load on the auto scaling group basically. So this is to handle traffic spikes without manual intervention. So this was a completely automated solution that I built to have like a proactive monitoring and solution for CPU utilization that increases from time to time on our EC2 instances. Then also we had an external a penetration tester as well. So we had an external team who used to perform penetration testing on all our infrastructure. So for that, I had to regularly configure the access so that they can have an insight on our infrastructure and perform this test, and then they can share the results. So what we used to use a Kali Linux operating system there, which is a very popular penetration testing OS which you can use. So we used to use Kali Linux virtual machines there to configure this type of access to the external penetration testers, and then they used to perform all the tests and then they used to share the results. So my job was to provision this new Kali Linux virtual machine and configure their external access so they can access to this machine, and from here they can access all the other machines. Okay, so all this access had to be controlled. Okay, so they should only have access that they need and nothing extra. So all this were part of my cloud engineer responsibilities. Okay, so these are the 14 points. I think this is good enough for you to explain in the interview along with the projects that I just explained. So I hope you like the video. If yes, please hit the like button. Please share this video with others, and please do subscribe to my channel. All right, guys, that's all for this one, and I'm going to see you in the next one. Bye for now.